Hey everyone. So let me ask you something. If you're working in cybersecurity right now, maybe you're a CTI analyst, maybe you're grinding it out in the SOC, staring at alerts all day. Have you ever felt like you're just reacting? Like you're always one step behind the bad guys, waiting for some vendor's black box tool to tell you something went wrong? Yeah, I've been there too. But if I told you there's a career path that flips that entire script, a role where you become the architect of the defense, where you decide what gets detected and how, where you're not just using the cookbook, you're writing it. Welcome to Detection Engineering. And I'm not exaggerating when I say this might be one of the coolest, most in-demand, and most intellectually satisfying career paths in cybersecurity right now. By the end of this video, you're going to understand what detection engineering actually is, why it's exploding in demand, and, most importantly, how you can transition into this role and level up your career. Let's dive in. Okay, so first, let's talk about why this discipline even exists. And to understand that, we need to talk about something called the detection gap. Picture this. You're a blue team defender. Your job is to detect threats. But across from you, there's a threat actor, an adversary, who is constantly evolving their techniques to evade your defenses. They're adapting, innovating, and getting sneakier. This creates a gap, the detection gap. It's the difference between what the adversary can do and what you can actually detect. And historically, we've been losing that race. Why? Because most organizations have been stuck in a reactive mindset. They deploy vendor tools, Splunk, CrowdStrike, whatever, and they just wait for an alert, wait for the tool to tell them something's wrong. But here's the brutal truth. Vendors are great, but they have three massive blind spots. One, they don't know your environment like you do. That admin tool, totally normal in 99% of companies. But in your high security environment, that is a red flag. Two, they don't have tailored intelligence for your threats. A financial services company faces totally different adversaries than a healthcare provider, but you're both getting the same generic detections. And three, and this is the kicker, they don't disclose their detection logic. It's a black box. You have no idea if they're even detecting the thing they say they are. You just have to trust them. So what do? You can't just sit there, blind and reactive, hoping your vendor catches everything. That's where detection engineering comes in. Detection engineering is the systematic, proactive approach to closing that gap. It's about taking control. It's about building custom detections tailored to your environment, your threats, and your risk profile. It's the discipline that says, we're not waiting for the bad guys anymore. We're going on the offensive. But what does this actually mean day to day? What does a detection engineer do? Let's get into the specifics. What is detection engineering? Alright, so what is detection engineering? Really? At its core, detection engineering is a structured, repeatable process for designing, building, testing, and deploying threat detections. But it's so much more than just writing detection rules. If the old SOC model was like being a line cook, someone hands you a recipe, you follow it, you serve the dish. Then detection engineering is like being a chef. You're researching ingredients. You're experimenting with flavors. You're creating the recipes that everyone else will use. Here's how it works. Detection engineers pull from three main sources. First, there's cyber threat intelligence. Your CTI team says, hey, APT29 is using this new technique. That becomes a requirement for a new detection. Second, purple teaming. You run simulations, red team versus blue team, and you discover we have zero visibility into this lateral movement technique. That's a detection gap. It's time to close it. Then third, we have threat hunting. Your hunters are out there proactively digging through logs. They find something weird, something that slipped past your existing defenses. Now that becomes a detection that you fortify and automate. And then, and this is the cool part, detection engineers don't just throw a query into Splunk and call it a day. They follow an entire life cycle. They research the technique. They design the detection logic. They test it against both benign and malicious data to make sure it's not going to flood your SOC with false positives. They then deploy it using a CI/CD pipeline, just like software engineers. And then they monitor it, tune it, and eventually sunset it when it's no longer relevant. This is what we call detection as code. You're treating your detections like software, version control, automated testing, peer reviews. It's engineering, not just vibes. And the result? You get high fidelity, precise, actionable detections that actually catch real threats without drowning your analysts in noise. Okay, so that's the what and the how. But why is this approach so much more effective? To understand that, we need to talk about causing pain. The pyramid of pain. Now let me show you why this approach is so devastating to attackers. Have you heard of the pyramid of pain? This is a model by David Bianco, and it's basically the entire strategic philosophy of detection engineering in a single graphic. At the bottom of the pyramid, you have things like hash values and IP addresses. These are trivial for an attacker to change. You block their malware hash? Cool. They recompile it in 30 seconds and now it has a completely new hash. You block their IP address. They spin up a new server. Zero effort, zero pain, especially with cloud computing. But as you climb the pyramid, things get harder for the attacker. And at the very top, you have TTPs, tactics, techniques, and procedures. This is how the attacker operates, their behavior, their methodology. And here's the beautiful part. If you detect an attacker's TTP, like say their specific method for dumping credentials, or their lateral movement technique, they can't just change a hash. They have to completely re-engineer their attack. They have to go back to the drawing board, redesign their tools, retrain their operators. That's expensive. That's time consuming. And most of all, that is painful. Detection engineering is all about climbing to the top of that pyramid. It's about focusing your defenses on adversary behavior, not just static indicators. When you do that, you fundamentally shift the economics of an attack. You make it so expensive for the attacker to evade your defenses that they either give up or make so much noise trying to adapt that you catch them anyway. It's asymmetric warfare, and you're winning. This all sounds great in theory, but does it really work? Let's look at some real-world examples of detection engineering. The real-world impact. Okay, let's get concrete. What does this look like in the real world? Case study number 1. A large healthcare organization was drowning in false positives. 60% of their alerts were noise. Their analysts were burned out, missing real threats because they were buried in junk. They then implemented detection engineering. They reviewed their existing rules. They profiled normal user behavior. They established a feedback loop. Within 6 months, it cut false positives from 60% down to 15%. Suddenly, their analysts could actually focus on real threats. Dwell time dropped. Response time improved. That's the power of engineered, high-fidelity detections. Or case study number 2. A financial services company hypothesized that an APT actor had infiltrated their network and was using living off the land techniques, basically abusing legitimate Windows tools to stay hidden. Their threat hunters dug into the telemetry and found suspicious use of Run DLL 32exe, executing malicious DLLs and abnormal WMI activity for persistence. Their hunt became a requirement for detection engineering. They built custom EDR rules to detect those specific behaviors, and now that entire class of attack is automatically caught. See the pattern? Threat intelligence identifies a threat. Threat hunting finds it in your environment. Then detection engineering automates the detection, and then the SOC benefits from high quality, pre-validated alerts. It's a beautiful loop. The skill set. Alright, so by now you're probably thinking, this sounds awesome. How do I become a detection engineer? Let's talk skills. And I'm going to be real with you. Detection engineering is not an entry-level role. This is a mid to senior level position that requires a pretty unique blend of skills. But if you're already in cyber threat intelligence or working at a security operations center, you're in a great position to make this transition. A detection engineer is basically a hybrid of 3 roles. Role 1, you're a software developer. You need to know Python, like really know it. You're writing scripts to automate deployment, validate detection logic, pull metrics from your SIEM via an API. You need to understand Git, CI/CD pipelines, version control. Detection as code isn't just a buzzword, it is literally how you work. Second, you're a senior SOC analyst. You need deep expert level knowledge of SIEM platforms like Splunk, Sentinel or Elastic. Pick your poison. But you need to master the query language, SPL, KQL, EQL, and you need to intimately understand MITRE ATT&CK. That framework is your entire worldview. It's how you classify detections, map coverage gaps, and prioritize your work. And finally, you're a security researcher. You need to understand operating system internals, Windows process injection, Linux privilege escalation, macOS persistence mechanisms. You need to know network protocols, malware analysis, forensics, because you can't detect what you don't understand. And it's that unique combination, builder, analyst, researcher, that makes detection engineers so valuable and so in demand. That is a powerful skill set, right? But how do you actually build it if you're not there yet? Well, let's break down a simple career path you can follow. The career path. So how do you get there? What's the path? The most common feeder role is SOC analyst. And honestly, if you're in a SOC right now, feeling burned out from triaging alerts all day, this is your level up. This is how you go from reactive to proactive, from consumer to creator. Here's what you need to focus on. First, get comfortable with your SIM's query language. Don't just run searches, build them. Experiment, optimize, become the person everyone goes to when they need a complex query to find evil in their environment. Second, learn Python. Start small. Automate something annoying. Parse a CSV file. Hit an API. Build from there. You don't need to become a full stack software engineer, but you do need to be script fluent. Then third, dive into MITRE ATT&CK. Map every alert you triage to a technique. Start thinking in terms of adversary behavior, not just indicators. Then step 4, start documenting. Seriously, write down why a detection works, what data sources it uses, what assumptions it makes. Get used to the idea that your work needs to be reproducible and shareable. And if you're a threat hunter, you're even closer. Detection engineering is basically the operationalization of threat hunting. You're already thinking proactively. You already understand TTPs. Now you just need to learn how to engineer that knowledge into repeatable, automated detections. So let's bring this home. Detection engineering is the systematic, proactive discipline that's redefining how we defend against modern adversaries. It's not about waiting for alerts, it's about creating the alerts. It's about climbing the pyramid of pain and making life hell for attackers. It's about building high-fidelity, tailored detections that are tested, validated, and continuously improved. And if you're in cyber threat intelligence or working in a SOC, this is one of the most exciting and rewarding career pivots you can make. You go from being a consumer of security tools to being an architect of defense. You're building something. You're creating impact. You're not just reacting, you're engineering. If you're serious about making this transition, start today. Pick one technique from MITRE ATT&CK. Research it. Find out what data source you need to detect it. Write a query, test it, document it. That is detection engineering. If this video helped you, or you get excited about this career path, smash that like button and subscribe. Drop a comment and let me know, are you already in detection engineering? Or are you thinking about making the leap? I want to hear from you. Thanks for watching, and I'll see you in the next one.